Hello everyone. Today, August 24th, 2025, marks a pivotal moment in space exploration. SpaceX is about to launch Starship Flight 10, a mission that could redefine our future as a multi-planetary species. Starship is the largest, most powerful, and fully reusable rocket ever built, designed to make Mars and beyond accessible. Flight 10 is crucial. After the partial success and failures of Flight 9, this mission is SpaceX's chance to prove it's learned, improved, and ready for the next leap. Each test, whether a triumph or a setback, brings us closer to a future where humanity isn't confined to Earth. Today's launch is more than a technical feat, it's a symbol of human curiosity and our drive to explore. The mission's success could accelerate lunar landings with NASA's Artemis program and set the stage for Mars. Think of it as learning to ride a bike. Every fall is a lesson, every attempt brings progress. SpaceX's iterative approach, build, test, fail, improve, is at the heart of engineering breakthroughs. Every flight, even the explosive ones, provides invaluable data. Today, from Starbase, Texas, we witness science in action and the relentless pursuit of the unknown. This launch carries the hopes of everyone who's ever looked up and wondered what's out there. The stakes are high, but so are the rewards. Let's get ready to watch history unfold. To understand Flight 10's significance, let's revisit Flight 9, a mission of triumphs and tough lessons. Flight 9 reached orbit, but a methane leak in the nose cone, caused by a damaged pressurization diffuser, led to loss of control and communication. Meanwhile, the Super Heavy booster, reused for the first time, failed during descent due to a high angle of attack, causing a catastrophic explosion just above the ocean. Earlier, a ground test destroyed another prototype, Ship 36, due to undetected pressure vessel damage. These incidents highlight the brutal complexity of rocket science. Every part must perform flawlessly under extreme conditions. But in spaceflight, failure is a teacher, not an enemy. Each setback gave SpaceX engineers critical data to analyze, adapt, and improve. The wreckage from Flight 9 told a story, and SpaceX listened. Lessons learned were quickly channeled into making the next vehicle stronger and more reliable. This relentless cycle of trial, error, and improvement is what turns ambitious dreams into reality. SpaceX's willingness to learn from failure is what sets it apart. Every failure is a step forward. Today's mission is built on the hard-won knowledge of every past attempt. That's the spirit driving Flight 10. Let's see what they've changed. After Flight 9, SpaceX engineers sprang into action, transforming failures into fixes. The methane leak was traced to a damaged pressurization diffuser, so for Flight 10, the system was completely redesigned for resilience. Rigorous pre-flight inspections now use advanced scanning to catch hidden flaws before launch. The Super Heavy booster's descent profile was changed to a shallower angle, reducing stress and preventing fuel tube failure. These targeted improvements show how real flight data drives rapid innovation at SpaceX. Instead of endless simulations, they build, fly, and learn fast. The result, Starship Flight 10, is tougher and smarter, embodying every lesson from its predecessors. The FAA's green light for this launch signals confidence in these upgrades. Now it's time to see if the fixes work. Flight 10's mission is SpaceX's boldest yet, pushing Starship further than ever. The Super Heavy booster will attempt a full boost-back burn, flipping and firing 13 Raptor engines to return toward Texas. Its landing test will use only 2 engines, deliberately disabling one to stress test stability and ignition systems. No tower catch yet, just a soft ocean splashdown to prove the sequence works. Meanwhile, the Starship upper stage will test new heat shield tiles with active cooling, vital for surviving re-entry at 17,500 miles per hour. The ship will also stress its rear flaps at max Q, ensuring they withstand extreme forces. A critical in-space engine relight will be attempted, essential for future Moon and Mars missions. Proving reliable engine restarts in space is a must for interplanetary travel. After its tests, Starship will aim for a controlled splashdown in the Indian Ocean. Every maneuver today is a step toward making Starship a true workhorse for the solar system. Even as Flight 10 launches, SpaceX is building the next-generation Starship version 3. V3 will be taller, more powerful, and able to carry even larger payloads. A key upgrade is a new catching point on the nose cone, designed for Mechazilla, the giant robotic arms on the launch tower. The goal: catch both booster and Starship on the pad, eliminating legs and splashdowns for rapid reuse. Imagine a skyscraper falling from the sky and being caught by giant chopsticks. Science fiction turned reality. Mastering this catch is the final step to true rapid reusability, enabling frequent launches for Moon and Mars missions. the first real catch attempts could come as soon as Flight 11 or 12. SpaceX's relentless improvement cycle, test, learn, upgrade, drives the program forward. Every flight, win or lose, feeds into this loop, pushing the boundaries of what's possible. The future of space travel is being built before our eyes. To launch thousands of Starships, SpaceX needs more than one pad. That's why they're transforming Launch Complex 37 at Cape Canaveral, building 2 Starship towers for rapid back-to-back launches. This dual-tower setup means one rocket can prep while another launches, true operational cadence. Florida's expansion adds redundancy, protects against delays, and enables diverse mission profiles. The site will be key for Artemis lunar landings and other major missions. SpaceX is also planning a gigabase at Kennedy Space Center, a factory-to-launch pad pipeline for mass-producing and launching Starships. Vertical integration is essential for the high launch rate needed to colonize Mars. Rockets are becoming less like custom craft, more like mass-produced vehicles. Ground infrastructure is as vital as the rocket itself. Today's launch is just one part of a vast, growing ecosystem. Where is all this leading? The answer: Mars. Elon Musk's vision is clear. Make humanity multi-planetary for our long-term survival. Starship is the tool, and the first uncrewed Mars mission could launch as soon as 2026, carrying supplies and robots to prepare for humans. But first, Starship will land astronauts on the Moon for NASA's Artemis program, with the Artemis III mission set for 2027. These flights demand rapid reusability and high launch rates, multiple Starships just to refuel one Mars-bound ship. Every test, engine relights, landing sequences, new launch towers, builds toward routine orbital refueling and interplanetary travel. Each success brings us closer to opening the solar system. Today's flight is more than a test, it's a step in a grand plan to make space accessible. The challenges are immense, but so is the drive to explore. SpaceX is turning science fiction into reality. One launch at a time, let's change the world.